before we get into the second part, and basically the second part is where I'm going to have to draw the triangles instead, just like the way we did with double angles. Now, that whole plus or minus sign gets to be really hairy when we start talking about these triangles on the chordate plane. Okay, so what I'm doing is just building up to hopefully get to see a pattern. All right, now let me fill the question in. Well, actually, we'll copy this so I can use it later. Okay, so let me throw in this right here. All right, if theta, and I'm going to put here from pi over 2 to pi. So what's the way to say that? Instead of just reading it literally. Theta is in between pi over 2 and pi. What am I talking about? Which quadrant? Second, right? That's second quadrant, isn't it? Pi over 2 to pi. Okay. Now, so let's answer this question right here, though. Okay. So if theta is basically, and this means in quadrant 2, where is theta over 2, though? Okay. So it's not going to be in the same quadrant. All right. So let me show you how you can figure this out. So let's start off with where was theta to begin with? All right, it was in the second, which would be in between pi over 2 and pi. Okay, now to find out where theta over 2 is, what I'm going to do is just take theta right there and divide by 2. Now, if I divide this by 2, though, got to divide everything by 2. So I divide this by 2 and divide this by 2. Okay, and by the way, when we ask where is theta over 2, what's another word for saying theta over 2? This is called the half angle. Okay, so if the angle's in quadrant 2, what quadrant is the half angle going to be in? All right, now, so let's work this out. You have to follow me right here, especially on this part. What's pi over 2 over 2? That would be like pi over 2 times 1/2. So it would be pi over 4. Okay, so we get pi over 4 right there. And then this part right here, that's just pi over 2. Okay, now think about it. From pi over 4 to pi over 2, that's in the first quadrant, isn't it? Okay, so where is the half angle going to be? It would be in quadrant 1. All right, so kind of look at the whole question here, and we're going to develop a pattern. So if my angle is in quadrant 2, then my half angle will be in quadrant 1. Now, why is it important where the quadrant is? Think about the big picture. The sign. Okay, because what do I have to decide on sine and cosine on my half angles? I got to decide, is it plus or is it minus? Okay, and see, this is where it gets really confusing. Even though the angle is in the second quadrant, even though theta is in the second quadrant, the half angle would be in the first quadrant, which means everything would be positive if I was talking about a half angle. Now, let's look at this question for like quadrant 3. Okay, so this time, just to be a little bit different, I'm going to put this one in terms of degrees. Okay, let's say that we're in the third quadrant. So that would be in between 180 degrees and 270 degrees. But that's quadrant 3, isn't it? Okay. Now, so where is the half angle going to be? What quadrant would it be in? Now, let's use the same logic, and let's take that inequality. And so how do we figure out the half angle? What do we do with the angle? We divide by 2, and that makes it the half angle. So if I divide that by 2, got to go over here and divide by 2, and got to go over here and divide by 2. So now this is going to give me 90. Somebody help me out. What's 270 divided by 2? 135? Not everybody at once. All right, 135. Okay. So now, where was theta at? Quadrant 3. All right. Now, so if theta is in quadrant 3, now what about the half angle? So where would in between 90 degrees and 135 degrees be? Second quadrant. Okay. So where is the half angle? The half angle would be in quadrant 2. So if my angle is in quadrant 3, then my half angle would be in quadrant 2. Almost. You'd think that, wouldn't you? All right, but watch the next one. Now, here's the nice one. If the angle's in quadrant 1, then the half angle's in quadrant 1. Okay? Because if I have something positive, does it turn negative? No, it stays positive. So if the angle's in quadrant 1, the half angle's in quadrant 1. Now, let's look at quadrant 4. You probably know that that's coming. So how could I label quadrant 4 from what to what? Either way, whatever way you want to do it. Let's just do radians. That would be from 3 pi over 2 to 2 pi. Okay. So now let's find out, where would the half angle be? All right. So do the same thing. I'm going to divide by 2. And after this, we're going to summarize this whole thing. Okay. So what's 3 pi over 2 over 2? 3 pi over 4. And then 2 pi over 2 would just be pi. Okay. So now, if my angle is in quadrant, that's quadrant what there? Right here. That's quadrant 4. Okay, I'm sorry. Should ask what was it? What this one? Okay. So if that's in quadrant 4, then the half angle between 3 pi over 4 and pi would be in quadrant 2. So it's not always back to quadrant like you would think. Okay. So this would be in quadrant 2. Okay. So now let's summarize. Let's take basically the 4 things that I just worked out and put it all on one page. Okay, so this is probably what you need to write down more so than all the work here. Okay, so you could work it out every time right here, or you could just memorize these 4 things. Okay, let's just use alpha. Okay, so if alpha is in quadrant 1, then alpha over 2 is in quadrant 1. Okay, so if I'm in the first quadrant, if I half an angle in the first quadrant, does it throw me into another one? No. Okay, because it's not going to make it negative, is it? All right. Now, what about this one? All right. If alpha is in quadrant 2, all right, what happened there? Let's go back. Right. All right, remember this? That's quadrant 2, right? What happened to the theta over 2? It wound up in quadrant 1. Okay, so I'm going to do this. All right, now, what happened when alpha was in quadrant 3? Right, it went back to quadrant 2. Okay, so it always looked like it was just backing up a quadrant from these 2. All right, but it didn't work that way with the last one. The pattern didn't really keep up. So if alpha is in quadrant 4, right, it just went back to 2. Then alpha over 2, which is the half angle, is in quadrant 2. Okay, so I can sort of remember these 2 things together. So if my angle is in quadrant 1 or quadrant 2, the half angle will be in where? Quadrant 1. Okay, if my angle is in quadrant 3 or quadrant 4, my half angle will be in quadrant 2. Now, why does all this matter? The sign, that plus or minus sign, right? Remember how I was all uptight about the sign yesterday? I'm even more uptight about it right now, okay? Because it doesn't really look at what the problem says. The problem says that you're going to be in a certain quadrant, but you're going to be finding the half angle, which is going to be in a different quadrant, okay? Now, let's actually look at some, like from your paper here. I'm going to do the two even ones here that go with 55 and 57. So I'm going to do number 56 with you, okay? Right. So they're going to be quadrant 1 and quadrant 2. So now one thing about it, that means the half angle for sine, if I'm in quadrant 1 or quadrant 2, would always be positive. Okay. Now, let's look at number 56. Okay. So now let me go through the directions first. It says use the given information to find the exact value of the following. So it says sine of alpha over 2, cosine of alpha over 2, and tangent alpha over 2. So what's another way of saying find what? What are we finding? The half angles. Okay, so find all the half angles. Now, on 56, they give you this information. They tell you that the tangent of alpha is equal to 8 over 15. And then what are they trying to tell you with this statement? Yeah, all right, right. They're telling you that you're in quadrant 3. Okay, now let's think about the formulas. What are we going to need for the half angle formulas? We need the cosine, don't we? So they gave us tangent though. So they gave us cosine. We could really jump into the formulas, couldn't we? Now, but they didn't give us cosine. They gave us tangent. So how can I get cosine? Right, sketch it out. Draw a triangle. Okay. Now, we're going to draw the triangle in quadrant 3. All right, now there's alpha. All right, tangent is 8 over 15. So what was tangent again? Opposite over adjacent. So this would be 8. This would be 15. Both would be negative. Okay, now do some calculations and find the hypotenuse for me. I'm pretty sure it's 17, but I want you to make sure. So 225 and 64 is 289. The square root of 289 is 17. Okay. All right. And they're really nice to you on these problems. I think every single triangle you're going to get in this test is going to be a triple. Okay. So that means probably no radicals. That's good news. Now, let's fill in our formulas. And now, again, what am I going to really need for the formulas? The cosine. So cosine of alpha there is negative 15 over 17. All right, so let's start with part A. Let's find the half angle for sine. So sine of alpha over 2 is equal to, according to my formula, plus or minus the square root of 1 minus cosine alpha over 2. Now, pay attention. This is where I'm like so uptight, I couldn't sleep last night. Okay, I'm so uptight about this. Now, what I'm afraid that you're going to do is you're going to say, well, I'm in quadrant 3, and sine is negative in quadrant 3. And that's wrong. Sine is negative in the quadrant 3. What are we trying to find the sine of, though? The half angle. Okay? Are we trying to find the sine of alpha? Mm-mm. We're trying to find the sine of alpha over 2. Now, this is why we went through that whole spiel just a few minutes ago about where the half angle is. So, look up here, if alpha is in quadrant 3, then alpha over 2 will be in quadrant 2. Now, in quadrant 2, is sine positive or negative? Positive. And you see how you could really get yourself screwed up there? So with all these triangle problems, you're really not going to look at what quadrant you're in right here for the half angle. Okay, the half angle is going to be in a different quadrant. Okay, I guess the only time it would stay in the same quadrant if it was in the first. Okay, now let's fill it in. So this is going to be positive. All right, now let's fill it in. 1 minus the cosine of alpha. So cosine of alpha was negative 15 over 17. So instead of saying minus negative 15 over 17, let's just say plus 15 over 17 over 2. Now, let's clean it up. So how can I clean this up so I can simplify? Right, multiply everything by 17, and that'll get rid of that 17 right there. All right, so big old honking square root. 17 plus, now, those are going to cancel out and just give me 15. And 2 times 17 would be 34. Okay, 17 and 15 is going to give me 32. Now, y'all notice that that reduces. And look what's going to work out really, really nice here. When I reduce by a factor of 2, right? What's the 32 going to turn into? 16, which is a really nice perfect square. The numerator always works out to a perfect square for some reason, okay? So it'll be the square root of 16 over 17, okay? Now, let's keep going here. The square root of 16 is 4. Square root of 17, I don't know that one. So we get 4 over the square root of 17, which would rationalize to 4 square root of 17 over 17. Okay, now part B and part C are going to go a little bit faster. Okay, now on part B, I think I'm going to do part B right beside it right here. All right, part B, we're doing just the cosine of alpha over 2. Okay, so this is just plus or minus the square root of 1 plus cosine alpha over 2. Okay, now the thing that I'm worried about the most is that sign. Okay, so let's think about it. Remember what we said. Where was alpha? Alpha was in quadrant 3. Okay, but where is alpha over 2 going to be? In quadrant 2. Now, cosine, what's cosine in quadrant 2? It's negative. Okay, so this is going to be negative right here. Now, the rest of it, I'm going to see if you guys want to use a shortcut. There again, look at the difference in the two formulas. What's the only difference there? The sign. Instead of 1 minus cosine alpha, it's 1 plus cosine alpha. So what I'm going to do is just go to this step and look and just tweak that formula a little bit. So instead of 17 plus 15 right there, it would be 17 minus 15, which would just give me 2. Did y'all follow that okay? See how you can just go to this step right here and just all you have to do is change that sign to get the cosine. Okay, so 17 minus 15 is going to give me 2 there. So I'll get the negative square root of 2 over 34. Now, y'all help me reduce it. So it'll be negative square root of 1 over 17. All right, the square root of 1 is 1. That'll be the negative sign in front of it. The square root of 17 is just square root of 17. Okay, now let's rationalize it. So that would be negative square root of 17 over 17. All right, now for tangent, what could we do for tangent now? Sine over the cosine. Now, let's see, that the first one, was that the sine? And the second one, okay, that will be clever, even though I don't have to. Here's the tangent. Oh, dang, I hit delete. I guess that's what I get for doing that. Here we go. All right. The sine over the cosine. That was it. Here we go. That's what you get for trying to be clever. All right, here we go. All right, so what's going to happen? This is tangent. Cancel. Okay, so we get 4 square root of 17 over negative square root of 17, and then square root of 17's cancel. So that would just leave me with negative 4. Okay? All right. Because they cancel. So that's another thing, a nice thing about tangents is everything's always going to cancel out real nice on the tangents. All right. Now, talk to me here. Do y'all want to do number 58 now, or okay, are y'all ready? I'll let you do this. If you want to go ahead and start trying this, go for it. Okay, I'll go ahead and do 58 for you guys that need a little help. Do what now? They're over there. Okay. Yeah, for homework, I changed that this morning. Let me write this for people who's watching it on the video. It's actually 50 through 52, and then 55 and 57. Okay. All right, let me do 58 with you. All right, so on 58, now you can actually be a little bit clever on 58 if you just think about it. You get secant of alpha is negative 3, and you have alpha here is in between pi over 2 and pi. So what are they telling me there? Quadrant 2. Now, I'm not too sure about secant. I don't like using secant. I don't like using cosecant, and I don't like using cotangent. I like sine cosine. So what can I do there? Right, change it to the reciprocal cosine. So if secant is negative 3, what would cosine be? Yeah, negative 1/3. So one thing about the reciprocal, the sign doesn't change on a reciprocal, does it? It's still going to be negative. Now, most of the time what we do at this point is we would draw a triangle, wouldn't we? But I don't need to. What do I need for my half angle formulas? I need cosine. Now you could draw a triangle. It wouldn't hurt. But if you have the cosine ratio, don't worry about drawing the triangle. We can go straight to the problem here. Okay, so part A, the sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. Now, plus or minus? Well, it's in quadrant 2. That's alpha, though. Okay, so if alpha is in quadrant 2, where is the half angle going to be? Quadrant 1. Now, that's pretty nice, isn't it? So this is in quadrant 2, but alpha over 2 is going to be in quadrant 1. And I like quadrant 1 because everything in quadrant 1 positive. Okay, so it's going to be positive there. And it'll be positive on cosine too, won't it? Now, let's fill this in. So 1, now minus the cosine. So what am I going to write there? Plus 1/3, okay, over 2. Now, I'm not going to show it this time. Let's just do it mentally here. Yeah, we're going to multiply by 3. Okay, so this is going to give me 3 plus 1 over 6. Okay, so now I'm going to be smart right here, though. This is going to give me the square root of 4/6. Now, I don't know. I'm thinking about reducing that to 2/3. But if you reduce it to 2/3, you lose your perfect square there, don't you? Okay, so what do y'all want to reduce it or go ahead and take the square root? I'm trying to think what would be easier. I say we just go with square root. I think that's going to be better in the long run. Okay, now if you try it the other, you're still going to be the same thing. Okay, all right, so this would just be 2 over square root of 6. Now, keep in mind, because it didn't reduce, I'm probably going to have to reduce the answer later on. So if you rationalize this, you're going to get 2 square roots of 6 over 6. And then that 2 over 6 would reduce to 1/3. So this would give you square root of 6 over 3. All right, now let's do, that was sine of alpha over 2. Let's do cosine of alpha over 2. So cosine of alpha over 2 is plus or minus the square root of 1 plus cosine alpha over 2. Now, what did we say is our half angle in quadrant 2 or quadrant 1? 1. So that means it's going to be positive. Okay. Now, you want to plug it in or y'all want to use our shortcut? All right. So my shortcut, I'm going to go right there. Right. 3 minus 1 would just give me 2. Okay. So I'll get the square root of 2/6. Now, I'm going to reduce this one because when I reduce 2, I'm going to get 1, and 1's a perfect square. So, sometimes you reduce, sometimes you don't. So square root of 1/3. All right, square root of 1 is 1. Square root of 3, I don't know. Now we'll rationalize to square root of 3 over 3. All right, now let's do the tangent. So tangent is sine over cosine, alpha over 2. All right, the sine was square root of 6 over 3. The cosine was square root of 3 over 3. Okay, these will reduce or cancel. So now, what about this? Normally the square roots cancel, but they don't this time. Now, can I reduce square roots like that? Can. As long as both of them are square roots, it's okay. Okay. So normally we say 6 over 3 is 2. This is just going to be square root of 2. Okay. Now, if you rationalized it and did it that way, you'd still come out with the n with square root of 2. Okay. Yes. Uh-huh. Uh-huh. Yeah. You want me to get you started on number 50? Okay. Now, you realize you're going to use your alpha triangle there, right? Okay, this is number 50. This was 24. This was 7. So the hypotenuse was 25. Okay, and you're looking for, on number 50, the sine of alpha over 2. Okay, so I'm just going to plug into my formula. And there again, what do I need to plug into my formula? What ratio? Cosine. Okay, so let's write up here that the cosine of alpha is 24 over 25. Okay, so it's equal to plus or minus square root of 1 minus cosine alpha over 2. Now my fish has an eye. All right. Now, so all you got to do is plug in for cosine alpha. You're going to plug in 24 over 25. All right. The plus or minus sign. It's just a plane triangle. It's not on the coordinate plane, so it's just going to be positive. It's like when you draw a plane triangle that everything is in quadrant 1. Everything's nice and rosy and positive. Right, 50, yeah, 50, 51, 52. Okay, those will all be positive. All right, we good with this? Good. All right. Let's see how many of you mess up the sign. I I I can sit up here and like turn red in the face preaching about how to do the sign, but some of you will still just not listen.